External forces. To move or stop an object of finite size, we have to apply a force on the object from outside. This force exerted on a given system is called an external force. A system is said to be isolated or at equilibrium if the sum of all the external forces on this system is null. That is, sum of F external on, this slash means on the system, equals zero vector. And this general expression is expression for vectors. So we have to deal here with the forces as vectors. This means that when we have a summation of vectors equal zero vectors, this means that the sum of all the x components should be zero and the sum of all the y components should be zero. So in document 3, we have a girl called Layan of mass 15 kilograms sitting on a swing. Layan is subjected to three forces as shown in the figure, T, F, and W. And she is said to be at equilibrium. The question is to determine the magnitude of the tension T. Now, in order to calculate the magnitude T, we have to make use of the given, which is the mass. We can calculate the weight equal m times g, 15 times 10, 115 newtons. So now we have the weight and we have the magnitude of the F vector. We have to make use of the other given, which is being at equilibrium. So we have to apply here the equilibrium condition, which says that the sum of forces is equal to zero vector. So we have T vector plus F vector plus W vector equal zero vector. Now, these all vectors are not collinear, so we have to find a way to find their sum or to deal with them. We can notice that F and W are special vectors because they are perpendicular to each other. And we learned before that the sum of two perpendicular vectors is equal to the diagonal of the rectangle that forms them, from which is it's equal to the diagonal of the rectangle formed by the two vectors. So we call this diagonal T prime. Then F plus W, I can say that T vector now plus T prime is equal to zero vector. Moving T prime to the other side, we have T vector equal minus T prime. This means that T and T prime are two collinear vectors having the same magnitude but opposite direction. The minus sign here shows that they have opposite directions. So because of that, we can say that T equal T prime as a magnitude because we're looking for the magnitude of the tension. And we can find the magnitude of T prime by applying Pythagorean theorem here. We can see that this is a right triangle and you know that opposite sides in a rectangle are equal, so this is F and this could be considered to be F2. So T prime, which is the hypotenuse, is equal to radical F squared plus W squared, and the magnitude of the vector of force F squared plus the magnitude of W squared radical, so we get 234.30 Newton. This is T prime, but we already proved that T is equal to T prime, so T is also equal to 134.30 Newton. Now part to determine the angle theta. In this diagram also, in the same triangle, I want theta, and now I have the magnitude of T prime, I have the magnitude of F, I have the magnitude of W. There are three methods to find theta, either by using tangent or cosine or sine, but the most preferable one is using tangent because tangent is equal to opposite over adjacent, and the two values of and the opposite and the adjacent are actually given on direct. So by using them, you are sure about your result. Tangent theta is F over W, 180 over 150 equal 1.2. Then on your calculator, you press on the button shift, then tangent, then write this value obtained here between parentheses in order to get the magnitude or the measure of the angle. And tangent minus 1, this is inverse function of tangent. You're going to learn about it later on in mathematics. Here I'm showing that if we want to use cosines adjacent over hypotenuse, we would use W over T prime and do the same thing. Then press on shift cosine to find the angle. or we use sine opposite over hypotenuse, so it's f over t prime, and then we press shift sign the obtained value in order to get theta.